In this lesson here, we're going to be talking about the definition of the derivative. So I've got a picture drawn for you, and let's see if we can make some kind of sense out of it. Okay, so I've got the purple line here is what we want to look at first. And the purple line is what I'm calling the secant line. And this purple line is intersecting this bluish green curve here, which is our function, and it's intersecting it at the point 0, 0, which I'm calling the origin, and some other point x plus delta x, comma f of x plus delta x, which is our y. Now I'm saying down here at the origin, I'm just calling the point. I'm calling this point x comma f of x because this point could be anywhere on the curve, but I'm centering it at the origin. Now what happens here when the secant line, as you can see, the slope of the secant line is decreasing. So we're now looking at this green line. I'm taking this point here and I'm moving it down the curve, right? And so now here's our new secant line, and we can see that the slope is getting closer to 0, and I move this point along the curve, and now here's our new secant line and our new secant line, and you continue to do this until this point reaches the origin and becomes the origin. So if the point, as I get closer and closer to the origin, now this distance between the x distance between this point and this point here, I'm calling that distance delta x. So as you can see back up here in our first secant line and our first point on the graph up here, this is x plus delta x. So x is the x coordinate at this point, and then you add some delta x, and we add, you see this line here, I've got this adding, right, the x plus our delta x. So that's like a new x here. But what happens when delta x gets smaller and smaller and smaller and smaller and gets closer and closer to 0? Well, this tangent line, or this secant line, becomes what's known as the tangent line. So if I got really close here, right, we would be getting closer and closer from our secant line going to our tangent line. Now to find the slope of the secant line, we just use the slope formula. And this m, remember, usually stands for slope, and I'm calling this the slope of the secant line. So to find the slope of a line, we got 2 points, and it's our difference in our y values, which is the f of x plus delta x minus the f of x, right? This is our y value here, and then our other y value was the f of x plus delta x, and then you take the x plus delta x minus an x, and you end up with, once simplifying, just the delta x. Now to find, we said that as our delta x gets smaller and smaller, it approaches what's called the tangent line. Well, here it is. This is the definition of what's called the derivative, and that gives us the slope of the tangent line, or actually will give us a function that will give us the slope of the tangent line at any given point we ask it for, and we call this f prime of x, which is short for all of this stuff here. Now let's look at our curve here, which is in black, and some points on the curve, and I've drawn some tangent lines so you get kind of a feel of what the tangent line looks like. So this green curve here, this is tangent to this point here, which happens to be a maximum, and that's going to become very important later on in the story. Here's a tangent line. This bluish green line, here's a tangent line. This is a tangent line here at this point. Right here we've got another tangent line. This is considered to be our minimum. The purple line is not a tangent line, but it is a secant line. So I hope this gives you an idea of what the tangent line is.